everyone, and welcome to this brand new section called trigonometry, and today is simply the introduction. So please remember this, that you can use the following, everything that you learn in this lesson, when you have a right angle triangle only. Okay, so please remember this. Now, what are we looking at today? We're actually looking at what does it mean when we get the sine of an angle. Now let's just call the angle for today alpha. Or what is it if we get the cosine of an angle? Or what do we calculate when we get the tangent of an angle? We're actually not getting angles, we're getting a number value. Now what does that number value represent? Now I'll show you quickly. What if we have the sine of 30 degrees and we calculate it? Then we will see that our answer is a half, or 0,5. That half is not an angle. It's actually two sides of a right angle triangle, simply written as a ratio. So we divide two sides of a right angle triangle and that gives us that value. Okay. So when we calculate the sine of 30 degrees, we get a half. That half is actually two sides of a triangle represented as a ratio. Now, each one of these have two different sides that we actually divide with one another. For the sine of an angle, in this case the sine of alpha, we always take the opposite side of a triangle divided by the hypotenuse. For the cosine, it's the adjacent side divided by the hypotenuse. For the tangent of an angle, we take the opposite side divided by the adjacent side. Now, this is for you to memorize, and I will show you how we can spot which one is which. Okay? So here we have a right angle triangle, and to get the hypotenuse, it's not very difficult. Okay, there's the hypotenuse there for the sine and the cosine, and we want to know which side in this right angle triangle is the hypotenuse. Well, do you remember from our Pythagoras lessons that we can use our thumb and index finger, and when we put it on the triangle's 90 degree, our thumb and index finger represents the base and the height, right? So if this is the base and that is the height, then AB will be my hypotenuse. So this will be my hypotenuse. Okay, brilliant. So now I can put my thumb and index finger away. And then how do we spot now which is my opposite and my adjacent for a certain angle? Now here we have alpha. We want to know the sine of alpha. So that's not alpha, that's beta. Alpha is over here. So then I'm going to use my eye to show you quickly. And I'm going to change my eye and put it like this so you can see what I'm trying to do. I'm actually viewing this triangle from this side, from the angle which we have. We have the sine of alpha, so I'm viewing it from this side. Okay, and if I keep on watching it from this side and I go all the way through, then this AC will be my opposite. It's opposite the angle. Okay, so that is my opposite side. And the one that is actually the side that is touching the hypotenuse and that angle, that will be my adjacent. So this BC is actually touching the angle alpha. So this will be my adjacent side. So now if we want to express the sine of alpha in terms of the ratio of the sides of this triangle, I will say the following. So this will be equal to, which side is my opposite? It's AC. So my opposite side is AC divided by my hypotenuse. That's my hypotenuse, which is AB, right? So divided by AB. Great. So I'm going to put this I away for now. And then we continue with the cosine of alpha. So the cosine of alpha will be my adjacent, which is BC. Let me write it here as BC divided by my hypotenuse, which is AB. So there we go. So now we know that the cosine of alpha is my adjacent divided by my hypotenuse, which is BC divided by AB. how about the tangent of alpha, which is the opposite side divided by my adjacent side? Now, all of these ratios you have to memorize, okay? You have to know that the sine of alpha is the opposite divided by the hypotenuse. And then you go and identify them, and then you know which sides have to be divided by which sides. Okay, so now for the tangent of alpha, we've got the opposite side divided by my adjacent. That is my opposite, which is AC. So I can write here, this is AC. And then my adjacent is BC. So it will basically be AC divided by BC. So if we actually have values for these sides, for example, the opposite will be 8 and BC will be 4, then that will be 8 divided by 4, which is 2. Okay. So it's not that hard. You just have to know how to identify your opposite side and your hypotenuse and your adjacent side. Now, I'm going to scratch these out. So now we are going to try and identify the sides for the sine of beta. Now, beta is not the same angle as alpha. There is beta. So now, if I'm going to use my hand again, I know that my thumb and my index finger makes up the base and the height. So this will stay my hypotenuse, right? Okay, so let's put that away. Then we use our eye and we go put it there because now we're talking about the sine of beta. So that means I am viewing this angle from this side all the way through, and the side opposite the angle is my opposite side. So this becomes now my opposite side. So BC is the opposite side to the angle beta. And AC touches this angle and it's not my hypotenuse. So this will be my adjacent side. So let me write here my adjacent. Okay, great. So now let's go and write the sine of beta in terms of the sides that's given here in the triangle. So the sine of beta, any sine is always my opposite divided by my hypotenuse. So the sine of any angle is the opposite side divided by the hypotenuse. Now this is my opposite, which is BC. So I can write here, and I'll do that in blue. So it's BC divided by my hypotenuse, which is AB. Okay, great. Now, how about the cosine of beta? Now the cosine of beta will be my adjacent, which is AC. Okay, so let me write that, which is AC divided by the hypotenuse, which is AB. Okay, great. And now, how about the tangent of beta? The tangent of beta is always my opposite divided by my adjacent, so it's BC divided by AC. So it will be BC divided by AC, and we are done. So it's so important that you remember that the sine of any angle is always the opposite side divided by the hypotenuse. The cosine of any angle is always the adjacent side divided by the hypotenuse. The tangent of any angle is always the opposite side divided by my adjacent side. And the opposite and adjacent always changes depending on which angle we use. We're always viewing it from that specific angle. Okay, so if we're viewing it from beta side, then this will be my opposite and this will be my adjacent. If we are viewing it from alpha side, this will be my opposite and this will be my adjacent. Okay, great. Now, so what does all of this mean? First, you need to understand that the sine and the cosine or the tangent of an angle gives me an answer which is a ratio of two sides of a right angle triangle. Okay. So when we divide these two sides, we get an answer which is a simplified version of these two sides divided by one another. Okay, then we can use this to determine the length of a side or an angle for a right angle triangle. That's what we're going to do later on. But first, there's still a couple of lessons where you're just going to learn how to use your calculator, how we are going to manipulate equations with the sine and the cosine and tangents of angles, and then we will see how we will use this in order to calculate missing sides and missing angles for right-angled triangles. Let's go and try some more examples. Now in this section we are going to practice writing the cosine, the sine and the tangents of angles in terms of the ratio of the sides. So state the following in terms of the triangle sides and then its values. So the first thing I want you to do is line up the sides, tell me which sides get divided by which ones, and then go put in their actual values. So don't forget that the cosine of an angle will always be the adjacent side divided by the hypotenuse. Now, this is not given to you at any time. You have to memorize that the cosine of an angle is the adjacent side divided by the hypotenuse. Now, how will we establish where the adjacent and the hypotenuse is? So, first of all, I use my thumb and my index finger. I put it there. So now I know that AC is actually the hypotenuse. So I'm going to write that in red. So this is my hypotenuse there. Okay, great. Now I can put my hand away. Then I go and take my eye and I put it there because I want to know the cosine of alpha. So I am viewing this from this side all the way through. So the side opposite alpha is my opposite. So there we go. So this will be my opposite. And then that means the one touching this angle, this side, will be my adjacent. So this will be my adjacent side. Now I can match the two. So my adjacent side is, and if I put my eye away, will be AB. So I can write here that this will be AB divided by my hypotenuse, which is AC. And I can write here AC, and then I can put in their actual values. AB, this one is a 4, so that will be 4 divided by an AC, which is a 5. So it will be 4 over 5, and there we go. Okay, great. Now, how about the sine of beta? Now, this can get confusing. So the sine of beta, and I'll do this in blue, the sine of beta is basically my opposite divided by my hypotenuse. Okay, so you have to memorize that. Now, if we look from the side where the beta is, now we already know that this will be the hypotenuse. It stays the hypotenuse. Now, if I put my eye here, I'm viewing it from beta side because I want the sine of beta. So this will now be my opposite. Okay, so I'll do that in blue. So this will be my opposite for beta. And then we know that BC is my adjacent for beta because this side is the one touching beta. So this will be my adjacent. Okay, now let's do this. So don't get confused, okay? So my opposite is AB. So let's write that. So that will be AB divided by my hypotenuse, which is AC. Okay, so this will be AC, and that equals to 4 over 5 again. So basically, the cosine of alpha, which is 4 over 5, is the same as the sine of beta, which is 4 over 5. Okay, now, how about the tangent of beta? So the tangent of beta, you have to memorize this. It will always be my opposite divided by my adjacent side. Now, if we view from this side again, we know that this is my opposite, so AB. So that will be AB divided by my adjacent, which is BC. And there we go. And if we put in the values, it will be 4 over 3. Okay, great. So, remember the blue ones are when we view it from beta side, and the red ones when we view it from alpha side. Now, we want the sine of alpha, and the sine of any angle is always my opposite divided by my hypotenuse. So this will equal to, we're looking at the red ones because we're talking about alpha, right? So this will be my opposite, so it's BC. So there we go, and the hypotenuse is AC. So that will be 3 over 5. There we go. And now how about the next one? The cosine of beta. We're viewing it from this side again, so we're looking at the blue ones. And what is the cosine of any angle? Expressed as ratios of sides. It's always my adjacent divided by my hypotenuse, right? So my adjacent for beta is BC. So we can write here that this is BC divided by, and the hypotenuse is AC, which is 5, right? So it will be 3 over 5. And again, look, The cosine of beta is 3 over 5, but the sine of alpha is also 3 over 5. Now, how about the last one? The tangent of alpha. Now, tangent of alpha, so that means we're viewing it from this side. That's my opposite, that's my adjacent. We're looking at the red ones. And we know that the tangent of any angle will always be my opposite divided by my adjacent. And my opposite in red will be BC, and my adjacent will be AB, and that is 3 over 4, and we are done. Okay, so I hope you could follow and understand how we write the ratios of the sides. It's so important that you memorize it, how you can spot these sides as well, because they will be very helpful later on. See you again soon. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.